Hello and welcome to another episode of Cooking with Unity. Finally. It's great to see you guys, even though I'm not seeing you live. This is a pre-recorded episode because my internet sucks right now. I'm hoping to get that fixed up by next week, and I'm hoping to make this a weekly thing where I do episodes again, at least one a week, get back into this. So, what I'm doing for this episode is, I was originally going to do it from Remake Jam, but I think that's actually over because I spent too long not doing this episode. But I'm still doing it. I'm remaking the original Cooking with Unity episode, the 3-episode series originally. Maybe less now, or it'll maybe more, and we'll make it cooler. But I'm redoing the little Space Invaders game that we did. And so first off, I'm going to just open that up and show what was there. And I want to note that this was actually made... this project was made in Unity 3.5. And... if we just open it up and hey, say I made a backup, go ahead, because this is saved somewhere, I'm sure. On the internet, re-download it from the episode. If we hit play, nothing will happen because we didn't load the scene. If we open the main level though, and hit play, oops, hit play twice, you'll see that we have a game. And it's actually not a terrible game. It's pretty easy. The enemies do get faster, though. We have a score. It has game over and win conditions. The enemies don't shoot at you, but eventually they get to the bottom and hit you. And all this works, and it's from versions forever ago. So the thing is, Unity stuff still stays pretty compatible over the years, which is great. People sometimes wonder if they should start my episodes with the ones that are in the Unity 5.0 era. It doesn't make a huge difference. The biggest difference is it changes some of the calls for grabbing your components, which automatically update themselves if you don't have that set up. So I mean, if you have it set up the old way. So that's what actually, when I clicked I made a backup, it was actually changing scripts to have the new terminology in them. So it's really surprisingly backwards compatible. This is usually 3.5. It is a simple game, but it works. We didn't have to do any tweaking. It's still a thing. But we're going to basically start making this again, and we're going to make it a little bit different than last time. We had a few different scripts here. I think we're going to have probably less scripts this time, and I'm going to use some new techniques that I've learned over the years and stuff that's been added to Unity, and hopefully we'll have some fun. So, when did I start this thing? We'll just say it started now. So, quit Unity. Why did I do a full quit? I don't know. Unity. So we're going to create a new project, and what are we going to call this? We're going to call it, we don't want Unity Analytics, and let's call it Space. Actually, I'm going to call it Invadesque. Invader-esque? I guess that's fine too, but Invadesque. Yeah, why not? Create project. Ooh, HoloLens DLL loaded. Alright, so, first off, this is not the layout I usually use when doing the show. I'm starting with the default layout here so that people know how I set it up. All of these little things can be moved around to different organizations as you see fit. And I'm just going to show you the one that I usually use. So, let's first move the hierarchy over to the left of here. So, now I've got hierarchy and project tabs. I don't like this fancy, weird, searchy bar thing, so I switch this to one column layout, and it becomes just a very simple flat text layout. There's nothing here yet, but it'll just eventually be a list of the files in our project. We've got this console thing. I like to drag this over here because you can usually read the console errors pretty easily, and you don't usually need the inspector on the console up at the same time, but you might want to be looking at what's going on in the game hierarchy and in the project here. And that's about it. You can leave the asset store here if you want, which I'm going to for right now. So this is our Invadesque game. So let's start by making something move. So we're going to create a 3D object, a cube. So here's our cube. If you double click on an item in the hierarchy, it will focus on that item and it will zoom in on it. So like if we were not looking at it, if I moved our view of it, double clicking on this cube will show it. This cube is just going to be a cube for right now, but we're going to make it into the player character. And so we're going to do that by writing a simple script to move it left and right. The first rule of making anything is to make something move. For making a game. as soon as you make something move, you feel a lot better about things. So, going to hit C# script, new behavior script. We're going to call this move. Oops, left. My built-in keyboard on my laptop here is dying on me, and so I'm using an external, and I keep forgetting to use it, so you'll occasionally hear me say whoops, probably, when I go to type. There I go, using the wrong keyboard again. So, move left and right. We don't really care about start for this, we just care about update. So, if you've never used Unity before, if it's your first video, if this is what you're doing, when you create a script file and double-click it, you'll see that it already has some stuff in here. And this is basically a class declaration for your file, and it automatically sets everything up for you in the right way. And so basically, in most cases, you're just going to be using code in the start and update functions here. And what start happens is, start happens at the beginning when the game starts or when this object is created. Whatever's in start will happen. And then update happens every frame, including the first frame after start. So what it does is, it's your main game logic. So each time that your computer draws a frame, it asks objects what they want to do. And this is what it calls. It calls update, and then you tell the object what you want it to do here. So in our case, we're going to make it so that this object can move left and right when we use left and right on the keyboard. So I'm going to create a couple variables up here first. Actually, I'm not going to make the variables. Let's just do it the raw way first, and then we'll make variables out of it, and then maybe you'll understand variables better. So we're going to be changing our position, which is represented in transform. So transform is a weird word for it. You know, transform, as you think about things changing shape and stuff. It really just means changing property of any kind. In this particular case, it's changing the spatial properties of the object. So the transform contains where an object is and how it's oriented. And this contains position information, which is what we're going to be changing. And we're going to be changing it based on input. So position equals... so I'm going to be using linear algebra this time. The first time I did the show, I did it with individual x, y components. And that probably would make more sense to people that they're used to using coordinate systems. But we're going to be doing some linear algebra. I'm just going to be jumping into the deep end here. Don't sweat it too much. You're not going to have to write a lot of this code at first. So we're going to use vector3.write. God, this keyword's not the same size as another keyword. Right. This represents a vector that points directly to the right. And we're going to use that as a direction to go. So basically, if we multiply vector3.write with a distance, it will go right in that distance. And so what we can use for the distance, though, is we can use something like input.getAxis. And we're going to use the horizontal axis, because this is predefined. When you create a new project in Unity, horizontal is already defined to be left and right on the keyboard. And what this function returns, this statement here is a function call. It's calling the function getAxis on the input namespace. Not namespace, but input class. And it's using this function. For input getAxis, you specify a axis name. So we just specified the name horizontal. It expects it as a string, and this returns a value between -1 and 1 based on the state of your controller. So if you have a controller plugged in, you press it all the way to the left, it'll return -1. If you press it all the way to the right, it'll return +1. If you press it in the middle, it'll return like 0.5 or somewhere in between. And it'll do that on the keyboard as well, but it's kind of virtual input style, so it has a little bit of a lead up, which you'll see as an acceleration. And so we do this, input.getAxis horizontal, and so we're going to transfer that position plus equals, we're going to add a vector to the right times input.getAxis horizontal. And I'm just going to start with that and just show what this does first. So save, I'm going to go back to Unity, and we have the script called move left and right, and we're going to put it on our cube. We're just going to drag it onto the cube on the left here, and now you'll see that it says move left and right. And if we hit play, if all goes well, when we press left and right, we move left and right. There we go. It's moving left and right. Now, it's moving pretty zippy, and we might want to be able to adjust that, and we can't adjust that right now. And so we can make some changes to the script that makes it so that we can adjust how this works. And we're going to add a couple features that make it work a little bit more consistently. So right now, what we're literally doing is we're going, if we're pressing fully to the right, we're going 1 unit per frame to the right. A unit is 1 meter. This cube is itself 1 meter. So it's moving itself distance each frame at full acceleration, which makes it cruise across the screen pretty fast. What we want to do is we want to be able to specify how far it goes per second rather than per frame, and we want to be able to adjust the amount. So I'm going to create a variable here called public float. So public means we want it accessible in the editor. That's the main reason we're declaring it public. Float means floating point value, which means any value between, it could be whole numbers or partial numbers. You can do like 1.5 or whatever, or 1.6252. And it has different levels of accuracy across the scale, but that doesn't matter too much for most purposes. It's a number with a decimal place. So we're going to call this variable speed. And I'm going to go ahead and give it a default value of, I usually use 6.0 F for speed just because 1.0 just always feels like a crawl in everything I've made. Probably doesn't matter what your defaults are, but I like to have ones that kind of work pretty well. So we need to use this variable now, and we're just going to add it into our multiply here. Remember, you could, if we want the speed to be 0, you put a 0 in there, and that would just make this whole statement 0. And if you put a 1 there, it would make it do exactly what it was doing before. And now, if you put any other number in there, it'll make it do times 2 or times 3. So this time it's 6 times, so 6 units. But we're still going per frame. That's because this is happening in update. Update happens every frame, so it goes here. It's like, hey, I should move to the right this amount for this frame. And then it says, hey, I should move to the right this amount this frame. And again, we get left automatically because input.getAccess returns negative if it's on the left. So a negative number times vector to the right makes a vector that points to the left. You'll get more comfortable with vector math as we go along, and I'm going to do some specials on that too. So finally, this is per frame. We want it per second, right? So we're going to add another multiply in here times time.delta time. This is a special value that Unity keeps updated for us that represents the amount of time that it's been since the last frame happened. And so this allows you to determine, hey, if that amount of time has elapsed, like say, it normally is 1/60th of a second, right? But if you have slowdown, say you have too much going on the screen, it goes to 30 frames per second, it'll be longer. So this allows you to move the proper amount, even if the frame took longer to render last time than it should have. So hopefully that was clear. It's been a long time since I've done this, so I'm still trying to get used to talking to the mic. Hopefully this episode's going okay. Cube, left and right. So we can move it left and right. Looks like it's doing kind of exactly the same thing. It's moving a little slower because time.delta time's in there. We can change the speed to 1 and it'll be really crawly slow now. No, it's not. It didn't change anything. Did I not save? I didn't save. Important to save. All that was just me thinking. So let's put this back to 6. See what happens when we hit play. It'll probably be slower now. There, now that's real. There we go. So it's going 6 units per second, so 1001. Yeah, that's about right. So that moved about 6 cube lengths. And we can make it slower now, so if we do 1, this is the reason why I don't do 1 as the default, because it's so slow. So yeah, and then we can make it 10 and it'll be faster. And the other thing is, when you're running the game, you can actually make edits to these things while it's running. So we could be like, hey, this is not fast enough. We could be like, hey, let's do 100. And then it's too fast, so okay, well, we can do less. And you can also click and drag on the speed here, and you can actually drag it down. So if you want to try and figure out a value, you can kind of like, well, I can't actually play the game and do it at the same time, but you can drag it and try some things. You don't have to do things with whole numbers, you know, you can just play with it in an analog sense. So anyway, I'm just going to leave it at 10 for now. So we can move left and right. Yay, that's one thing. So what else do we need? We need the ability to shoot. So let's create, let's create a bullet. So we're going to just create a another cube. And we're going to make this cube a bit smaller. So this cube is currently inside our first cube. It's in the exact same place. We can move it out if we want. The cube is at 0, 0, 0, and we've got the camera set up at 1 in the Y. I'm going to actually put it to 0 in the Y, so now our cube is right in the center. And I'm going to make it so that the background is just a flat color. We're going to switch it to solid color so that it's more like a 2D game and just has less distraction there. This is on the main camera. If you just set it to solid color, you'll get a solid color. And we're just going to leave it as, let's not use the Unity blue. Let's just switch it to pure black so that we know everything that's on there is something that we made. Yeah, we made a cube. Woo! Alright, so I want this cube to be small. I'm going to move it out of the way so we can see how it's changing. So this is the transform. So remember I said like transformers, but it's not really changing things other than position and rotation and stuff, but it also has scale, so we can actually change the size of things as well. So we can like shrink or grow this thing, and negative scales work kind of like positive scales, but avoid them. But you can do them; they're valid. Sometimes it makes sense. Sometimes if you want to flip a character around, a negative scale is a really good way to do that. So so let's just make this 0.1, 0.1. So these units actually correspond to meters. There was a time when you could argue that you can make the scale anything you want, but like in the days of VR that we are entering now, it's nice to know that these are meters. You can go into VR and this will be 1 meter by 1 meter, which is actually quite big. I mean, you can sit on this thing. It doesn't look like you could sit on this little cube when it's on a screen, but you could totally sit on this cube if we were doing it in VR, which we're going to be doing some VR stuff in the future too, because, oh, the VR future thing, man, I could talk all day on that. All right, sorry. Cube 1. We're going to rename this cube to Bullet. No, wrong keyboard. It doesn't help that part of the keyboard works. Specifically, what's not working is my T through O keys don't work. Well, I mean, I can sometimes massage them into doing a little bit of action, but it's a lot of rigmarole. And we're going to call this player. We're just going to give these some names. Again, I'm using the keyboard. And we're going to create a C# script. And we're going to call this shoot. Actually, you know what? We're not going to do that. We're going to do something a little different this time. I'm going to delete this. We're going to start using something that's, that wasn't there when we were last doing this episode. That makes it easy to kind of prototype and try ideas and write a little bit less code. So, saves things. Not that there's anything wrong with writing code, but writing less of it is sometimes nice, especially when you're doing prototypes. So I'm just going to call this level test, or just main. And we're going to, so we've got a player, we've got a bullet, and I'm going to create a C# script, and we're going to call this Unity, what are they called? Unity event on button down. Unity event on button down is what we're going to call it. We're going to use Unity events in here. So Unity events are hidden in another namespace. For some reason, they're not included in the main Unity engine space. So we have to do using Unity engine dot events. We could also not do this and just do Unity engine, just do events dot whatever for everything, but it's generally easier to just be able to declare them without the extra extrapolation stuff. So we're going to declare a public Unity engine event. We're going to declare a public Unity event, and it shows up, so that means that we got the namespace right. Public Unity event, and we're going to call this event. Actually, we're not going to call it event. We're going to call it events. Even though it's one event, you can actually do a lot of them, and event is a protected word for some reason, so I'm not going to use that. And then all we're going to do in this is we're just going to have something that happens when you press a button. We're just going to say if input dot get button down. And we're going to need a button name. So I'm going to go ahead and create a variable for that this time. So we're going to do public float, not float, public string, which means words, means a string of letters. I don't know why exactly they call it a string, but it's just a good word. Public string. Public string button name. I'm just making stuff up. So we're going to copy that. That's no. I just lost my keyboard. Okay, it's back. All right, yay. This keyboard has a Bluetooth connection button that's on function C, and my previous keyboard has function on a different key, so every time I go to copy, it's probably going to disconnect. So, get button down, button name. I'm smiling, at least that's good. Input.get button down, button name. So, if this happens, so what this little function does, I hate it when things try to adjust my... I'm going to have to change those settings. So, what this does is, if someone presses the button named button name, and actually I'm going to give it a default name of Fire1, because Fire1 is declared automatically in Unity. Like if you just create a new project, Fire1's already defined for you, and I think it's defaulted to control. It also is probably defaulted to your main button on a controller, so like A button if you're on Xbox 360 or something. So, input.get button down button name. So all we're going to do here is we're going to do events dot invoke, right? Yeah, invoke. And what that means is anything that has been set up in this Unity event, we're going to do. And that's when we press this button down. So, so yeah, so why did I do this? So what is a Unity event? How does this help us? So I'm going to go ahead and put this Unity event on button down on the player here. And this creates this new script here that now has Unity event on button down script. Button name Fire1. This is what we specified. Again, this is the default. And this events thing that says list is empty. And if we hit plus here, we can add things to it. And you can literally just drag objects in, like main camera or something, and then you can do stuff to it. You can be like, hey, I want to make it so that the camera turns off. So let's turn the camera off. So this is what state we're going to put it in. So we're going to put it to off unchecked. And so if we hit play here, and then I hit control, display 1, no cameras rendering. That's because we just turned our camera off. And that's something, I didn't have to write any camera code in here. I didn't have to do anything special. All I did was, hey, when we press a button, do the thing that we set up here, and now we can just set things up here. This is great. This is super useful. And so we can do anything that's on an object we can do. So this is where another technique I'm going to show you is. So there's a lot of things you can do on various objects, and you can do things on, like the audio listener has its own features, its transform has its own features. You can do a lot of different things here. But there's some things that it can't do right off the bat. But you can just add a script to it that has features. So we're going to create a new script called, I'm going to call it Unity Event Helper. Unity Event Helper. And this script, we're not going to use start or update at all in it. Well, we might use it later, but we're not going to use it for now. Actually, we probably won't use it later either. We're just going to create our own function here called public void. Void means we're not returning anything. We don't care about what the function, it's not going to return a number. Some functions in the old days always return something, and nowadays we do a lot of side effects where we just do stuff in a function, and so void means we're just doing stuff in the function. So this function is going to be called spawn. And actually, let's not call it spawn. Because that's conflating it with the network use. Let's call it instantiate. Instantiate prefab is what I'm going to call it. And all we're going to do is it's going to take a string, not a string. It's going to take a game object prefab, and all it's going to do is instantiate prefab at transform.position at quaternion.identity. So what this means, instantiate takes, well, actually there's a few different versions of the instantiate call. But the typical one that you'll see is this one right here. So you give it an object, the original that it's instantiating. So we're taking this prefab that we're going to pass in. I'll show you where that gets passed in a second. And then we're going to put it at a position. So we're just saying, hey, put it at the position of wherever this script is, wherever this object is creating this thing, put it here. And put it with the default rotation. So quaternion.identity is just the default rotation. It's like this. It's like putting a 0 here, but the 0 doesn't actually make sense because you need a quaternion there, not a 0. Quaternions are fancy for keeping gimbal lock away. It's kind of important for orientation so that it maintains degrees of freedom and stuff. We're not going to go into it in heavy detail on this because we're not going to have much rotations. This is mostly going to be a 2D game. So quaternion.id, we're going to see a lot of that. So I'm going to go ahead and save this. And something else I'm going to do is I'm going to go to Unity event on button down, and we're going to add something to this. We're going to add a require component call. And this require component call, we're going to use type of Unity, what do we call it? Event helper. Unity event helper. Why I'm doing this is this will make it so anytime we add this script to an object, you'll also get the Unity event helper script added to the object immediately as well. And so I'm not sure exactly how that works. Let's see if it automatically figures that out. So we're going to go to the player. Does it know that it needs to put that component on it? No, it does not. Let's see what happens if I re-add the component. Actually, let's try resetting. Let's see if I do reset. Does it do it? Nope. All right. So we're going to remove the component. We're going to add it again. Okay, so you can see that it added it there. So it won't automatically add it to the objects that are already seen. Probably a good thing so you don't accidentally break stuff. But now we have this Unity event helper. And so what we can do now is if we hit plus here, we can actually just, it's not very commonly known, but you can actually grab components by just grabbing them here. So we grab the Unity event helper, we can drag it into here as the object, and now our function under Unity event helper has instantiate prefab. There's a bunch of this stuff that just, because of the fact that it's a mod behavior, but instantiate prefab is the one we just wrote. So it takes a game object, and this is where we're plugging in that prefab. So we're going to now create a prefab for this bullet. We're just going to drag the bullet over here into the project, and that creates a prefab for it. That means that we can now, say we didn't have this bullet and we wanted one, we can just put a bullet here, shows up. We can put another bullet here. We can have as many bullets as we want, doesn't matter. They're all based on this bullet. And now we're going to place on the player our bullet prefab in here. And if all goes well, when we hit fire, we just created, you see it says bullet clone here. We can't tell it anything happened because it just created a bullet that just doesn't do anything. It just sits there. But we can create them, and we can create them at will. And we wrote a little bit of script, but we can now do a lot of things with this script without having to write each thing individually, and we can kind of play around with it. And I don't know, I like being able to just do things in the editor. I'm also a programmer. Sometimes it's faster to program things. Sometimes it's faster to do it in the editor. I like having a lot of power in a lot of places. Sometimes not great for project organization because you can get yourself into trouble, but it's great for prototyping. So what else are we doing? So let's make the bullet move. We could do this a couple of ways. We could either have the bullet be a rigid body that we just propel from the player, or we could make it so that the bullet has AI that just moves it through space. I think we're going to do the rigid body thing at first. I don't know. Both are appealing. There's less code in the rigid body, though. It's the same amount of code. I don't know. It doesn't matter. Let's do it. Let's go into Unity event helper. Let's create a new script called, instead of just instantiate prefab, we're going to say shoot what is it called? Rigid body. Rigid body. Oh wait, we can probably, I think we can only have one variable here. So yeah, this is definitely not the way to do this. Let's not do it this way. Alright, let's do it the other way. So we're going to give the bullet a little bit of AI. Really strong word for what it is. We're just going to call it bullet. Double click on this. And we already have seen some things, so I'm just going to start typing. Public float speed equals 6.0f. I'm going to drive some people with that 6 probably. They're going to be like, why is it not 5? Why is it not 10? Why is it not 1? It's 6. Why? Because 6 is good. And what we're going to do is it's going to be very similar to what we did for move left and right, because we just want to move it a little bit each frame, and we want to move it based on speed. But we're not going to need the input on this. We don't care. We just always want it to move at the same speed. So this is what we did vector3.right to go. We could do vector3.up if we wanted to go straight up. But it's more useful if a bullet can go in any direction, just in case we needed to shoot in a different direction. So I'm going to actually use forward, and I'll show, and this just makes things a little bit easier with the way Unity is set up. So we're going to use transform dot position plus equals transform. So we're going to use transform dot forward instead of vector3 dot forward, and this means we're going to use the facing of the bullet itself, and we're going to go that direction. And we're going to multiply this direction by our speed. And we're going to multiply this by time, delta time. And we're done. That's the whole thing right there. I'm just going to get rid of the start. We don't even need that. Moving left to right, I don't think it needs to start either. I'm just going to get rid of that while we're here. You can see how simple these are. You don't have to write a whole lot to get stuff done in Unity. So we're going to put this script bullet on our bullet. And now all of a sudden, the orientation of how we spawn this is going to matter. Because if we hit play right now, and we hit the attack button, you'll see the bullets are coming out, but I don't see them. Oh, they're not moving. Except for they actually are, whoops, they actually are moving. They're just moving out. Because we told transform.forward, and they're currently rotated at quaternion identity, which means that they're pointed forward into the scene. And so they're firing into the scene, which is kind of cool. We could make a little rail shooter on this, but we're not going to do that just yet. We wanted to shoot up. So let's change our spawn code here slightly. We used quaternion.identity. I said we were going to use this a lot. I lied. We're going to change it. We're going to instead use transform.rotation. So this means it'll use the position of the object the script is on, and it'll use the rotation of the object the script is on. And so now it's going to do exactly the same thing. If we just hit play again, and we shoot. No, it's not doing exactly the same thing. It's not firing. Oh, there we go. I was pressing the wrong button. I was pressing the function key. All right, so it's doing exactly the same thing. And that's because this thing, its forward, is the blue axis here, is pointed that way, and that's where the bullets are going. Normally we're looking at it from behind. Our camera's over there. You can see it pointed this way, looking at us. So let's just rotate this thing. We're just going to rotate it. So we're going to rotate it along its x-axis until it's vertical, which will be at 90 degrees, or negative 90 degrees here. And then if we hit play, and we fire, there we go. We're shooting up. There we go. Bullets are moving vertically on the screen. And I keep doing that because control and left and right on my keyboard switches my panels. So that's the reason that that's happening. And control is the fire button. Let's change that. Let's change what the fire button is so that we can be super confused later. I'm going to go to project settings, input. And this is where actually horizontal and fire one come from. So if we go to edit, project settings, input, this shows up in the inspector. And horizontal is defined here as left, right, or A and D on the keyboard. So if I go on my keyboard, I can check, hey, A and D goes left and right goes left and right. Very cool. And fire one is set up as left control and mouse 0. I'm going to go ahead and change this to be Z on the keyboard so that I can be like, it's not working. But I'm also going to use control as the alt. Oh, okay. Control. How do you wait? What was it before? Left control. If you type it in wrong, it won't allow you to do it. So we're going to call a positive button on here. What is it called? Z. Now, you'll notice there's two. So if we go down this list, there's actually a duplication of these controls. You'll see that there's fire one here. This is the button version of it. You can actually create multiple controls with the same name, and they will all operate under that. So if you have... You can create some conflicts this way, keep that in mind, but this is generally how you set up. You set up a set for the keyboard, and you set up a set for the joystick. I don't fully understand why they did it that way. There's totally enough here that they could have done all of it in here, maybe have a list of buttons as opposed to just like a set of, hey, here's one, here's another. But, you know, whatever. This input manager is kind of old now, and it's still, you know, it's not the greatest part of Unity, but it's there, and it's better than nothing. So we've got input. Let's see if the Z button works now. Yay, now I'm not switching. Now I can press left and right without switching windows. Although I think I still kept control right, yeah, so I can still mess myself up if I'm holding control. Yeah, okay, whatever. Hard to do when I'm trying to do it. So we've got players, we've got bullets. Let's create a bad guy. I'm just going to create another cube. Going to do all cubes all the time this time. Oh, it has a nice shadow. That's so cool. You don't have to have Unity Pro or anything now. Unity Basic does like everything now, which is great. So this is going to be an enemy. Let's make it look like an enemy. We're going to make it red. So I'm just going to create a material here. That's in the project menu. And we're going to call this material red. And all we're going to do is just set the color to red. Albedo or albedo. I think it's albedo. I don't know. That's your diffuse color. That's the reflected color of the object. And so if we just make it red, it'll be red. And then we can just drag this red onto this cube. Now we have a red cube. Could have also dragged it into the scene here. And I'm going to call this a enemy. Oops, enemy. All right, made it halfway through this episode, and I feel like we've still got a lot to go, but we've also got a lot to do. So remember, we got to the point that you saw at the beginning of the episode in 3 episodes. That's 3 hours, so give me at least that time to get back up to it. So we're going to create an enemy, and might as well start setting up our game a little bit. So I'm going to move the player down. We're just going to move the player down on the y-axis here a little bit. We'll just make it -3. That looks pretty good. And then we're going to move the enemy so that it's just in on the screen here a little bit. Alright, and actually we want an array of enemies. So let's just, last time I think I wrote a script for actually spawning an array, which is useful. We'll see if I break down and do that now, but I'm actually just going to use the editor a little bit. I'm just going to hit Control D to duplicate this. I'm on Mac. Command D to duplicate this. It's Control D on Windows, so I was right. It's not going to work on here. And we're just going to move him to the right here and just move him like 1.5 units over. Yeah, and we'll just keep doing that. Just duplicate again. Move it over. Duplicate again. Move it over. Oops, I didn't successfully duplicate. Did I not? Yeah. And this one's at 4.5 or something. Let's do 8. So I'm just going to now duplicate all of these. Oh, I did this badly. Okay, so we should have... so the one problem here is I didn't create a prefab for these guys first, and so now they're not based on a prefab, so I'm just going to... Sorry to put you through this again. We're just going to prefab with the first enemy, and then we're just going to delete all these guys, and just really quickly just D 1.5, click it again, D, Command D, 3.0, Command D, 4.5. Then we're just going to grab all 4 of these guys. See how the names are blue? That means they're based on this prefab. That means that if we make a change to this prefab, we can change all of them with it, and they're all connected. So that's great. So we're just going to grab these 3 enemies. I'm just going to hit Command D again. There we go. And now we're just going to grab this movement thing and move it to be about right. It doesn't have to be perfect. Actually, I'm going to hold... if you hold Command or Control on Windows, Command on Mac, you can snap to things, and I think the default snapping is helpful enough. So there we go. So we've got like a rack of enemies there. Let's go ahead and kind of center them a little bit. Doesn't matter. Create a whole new row, just Command D. Gonna hold Command after moving. Whoops. Oh, does it do it after? That's dumb. Wait, is that working? Yeah, close enough. That's good enough. One more row. And then we just move it again. There we go. We've got our enemies. And I'm just going to now create a kind of parent container for them. I'm going to create an empty container. We're going to call this enemy array. And we're going to just grab all these enemies and throw them in the enemy array. Actually, we want the enemy array to be in a sensible location. So let's have the enemy array... Where do we want it to represent? Let's have it represent the center of the enemies, or it doesn't matter. Why are you even caring about this, Max? I'm going to have it represent the center of the enemies, so we're just going to put it at 0, 0, 0, whatever. And then we'll put the enemies in the proper position for it. Somewhere about there. I'm going to drive people crazy if I don't make this accurate. Or I'm going to drive myself crazy, maybe. Or maybe it's good that I don't make it accurate. Maybe I should just drag it in and just, who cares that it's not exactly at normal values. Oh my goodness, I care so much. Yeah, let's undo that last move. I don't like that last move I did. Are these things at kind of normal values? No. No, they're not at normal values at all. Because I had already moved them or something. It doesn't matter, Max. Why are you doing this to yourself? All right. Thanks for watching at home, guys. Really appreciate you seeing my show. All right. I'm just going to move them visually, and I'm going to live with it. That looks about centered. That looks pretty good. I like that. We're just going to put that in the enemy array. Done. I don't know where we got a null reference exception. That's Unity. Just ignore that. Unity sometimes just throws out some stuff that doesn't make any sense. Probably because I'm duplicating too many things or something. I don't know. So now I got this enemy array. We can move the enemy array around. We can do like left and right in here. Before we had the enemies kind of separate of each other, which is cool too, but it's not as Space Invader-esque. So I decided this time we're going to group it up, and this time we're just going to do it in the editor because why not? And just ignore the fact that there's 0.72s and like a 7.2. Oh, good God. Yeah. So, we've got enemies. They're in an array. Let's make it so we can blow them up. So, we have these projectiles called bullets. I'm going to just drag a bullet in the scene. So, yeah, there's a little bullet just showed up some random freaking location. And we don't really have to change anything on the bullet other than we need to make sure that it collides properly. So, we're going to turn it into a trigger, which means that we don't want it to collide like a physical object. We just want it to check to see if it's collided with something. And so if it has collided with an enemy, then we will blow the enemy up, right? So it's a trigger, and I'm just going to hit apply here, and that applies it to the prefab. So now if you go to the bullet here, you can see that, hey, it's trigger. Before that point, if you make a change to something, you'll see it turns bold. That means that this has been changed from whatever it was on the prefab. And so if you see those types of things, that means that you have to save it to the prefab if you want by hitting apply. Sometimes you don't want to change. Sometimes you have changes for a particular item that you just want to keep. But in this case, we want this bullet to always be the master bullet. We're going to just be instantiating them. So let's make it so that the enemy does something when they get hit. So let's create a new useful script called Unity event on trigger enter. And this is going to be pretty much exactly the same as Unity event on button down, just slightly different formatting. So Unity event on button down, we needed Unity and engine.events. I'm just going to copy, paste that in. We needed a Unity event here. I'm just going to call it a Unity event. Events. And we're going to need to call events.invoke somewhere. So I'm just going to throw in an update. That's not where it's supposed to be, but I'm just going to do that. And we're going to rename update to be on trigger enter. This is a special function that gets called when an object touches another object that is a trigger, and that collision is valid. And all we're going to do is we're going to just invoke the events, and that way we can program it to do basically whatever we want by just using the event editor again. So we're going to go to our bullet here, and you can edit just in the project here, so I'm going to go ahead and do that. I'm just going to drag Unity event on trigger enter to bullet. Actually, let's not do it on the bullet. Let's do it on the enemy. So we're going to do it on the enemy here, and hopefully this will just automatically go to all the other enemies. So we're just going to drag Unity event on trigger enter to the enemy. Here we go. List is empty. All we're going to do is we're going to destroy the object. So we're going to have to add one more thing to the Unity event helper here. I'm just going to copy, paste. We're going to call destroy game object. I don't just call them destroy and just instantiate because those are kind of important. Sorry, is game object like that? I forget. Let's find out. Yeah, it's like that. So let's go ahead and make it the same. Game object with a capital O. Oh, it was right. I'm an idiot. Game object prefab. We don't need that. Yeah, we do. Game object target. And all we're going to do is destroy target. So we could have named this anything. It doesn't matter what you name it. It'll just show up in the editor portion. So if we now do, now go into the enemies, or sorry, we can go to one of the enemies, sure. We'll just go to one of the enemies here. We've got this Unity event on trigger because we added it to the enemy here, so it's on all the enemies. And we're going to change... Oh yeah, we didn't add this feature, which we should have. Unity event helper. You can go ahead and make that a required component for this one as well. And so now I'm going to show again if we remove this and then throw Unity event on trigger enter. We now have our event helper. We can drag the event helper into here and then call the Unity event helper destroy game object. And we can just destroy itself. So we're just going to drag the enemy itself into here. And then we're going to hit apply. And so now all our enemies should have this. And you'll see that they actually show themselves now. They're smart enough to actually... I was like, hey, I'm going to reference myself. That means, hey, I want to reference myself. It doesn't... I'm not referencing this enemy. I'm referencing myself. So now, in theory, these guys have colliders. This might just work. Let's find out. So we're going to fire a bullet, and we're going to see if we blow up some things. Nothing blew up. Not very promising, is it? Alright, so I think that's because neither object has a rigid body. And we're trying to do collision stuff. So we're going to add to the bullet a rigid body. Rigid body is a fancy term for... This is an object that can fall and bounce around and stuff, basically. It's something that doesn't change shape and doesn't have elasticity, but it can physically interact with things. But we're actually going to say is kinematic, which means we don't want it to physically interact with things, which automatically means the gravity's not going to happen, but I'm going to also turn off gravity because I like to uncheck that as well. It doesn't matter, but I'm going to do it. So, and that should be all we need to fix this. Sometimes you need a rigid body to actually handle the collision events. So we're going to hit play now. And I'm going to hit Z. Oh, it worked. Thank you. It didn't help that I missed that one time. I missed on one of those edges where it looked like it was actually on the thing. Yeah, because of depth. But yeah, no, it's working. Yay. So we have enemies, they can die. Hooray. Let's quickly do just a score system. Just really something basic. Even though the enemies aren't even moving yet. But let's just do that. We're going to create a, what are we going to create? We're going to create an empty object. We're going to call this the game manager. And we're going to create a script called game manager. And in our game manager, we're going to just have some data in here for right now. So I'm just going to create a public float. Actually, let's not make it a float. Public int score. Int means we just want it to be whole numbers, so we don't want 0.5 points. We could do a floating point score. There's no reason to not have floating point scores, but games don't usually do it. So we're just going to have the score, and let's go ahead and make it so we're going to make it fancy. We're going to use some C# magic to make this a little bit fancy. So we're going to also have a public float, public int high score. Just getting fancy. And so you can make specialized things that happen when you change things in a variable. You can do that using properties. So this is a property declaration. We're going to be just adding some brackets here. We're going to say when we set the score, when we set this. So what all variables do normally is they do score. Sorry, we need to have a backing thing too, so we need to have the actual score. So we're going to have private int, I'm just going to call it underscore score. Underscore score. This is actually what stores the variable. This is where we're going to store the score, and then this is where we're going to get it from. So we're going to just set the score. This is probably going to be confusing to people, but you know, if you just see it, eventually you'll have it as a tool. So score, wrong keyboard, right keyboard, but I can't type on it, equals value. And value is a special value that happens only in setters, that it represents what you're setting in here. So if you say score equals X somewhere in the code, it'll be like, hey, that means I should make this underscore score equal X. And why do we do this? Well, we can also do other things. So we can also do something like if score, underscore score, is greater than high score. Actually, I'm going to say greater than, yeah, greater than high score, whatever. Score is greater than high score. Put these on separate lines. Doesn't matter what line they're on. White space doesn't matter. You can put as many spaces or tabs or whatever between elements. But I try to keep it in a certain organization. Is evidently not the organization that MonoDevelop wants to keep it right now. So score is greater than high score, then high score equals score. Underscore score. Otherwise we'll have problems. We don't want to get in here and call itself again, because then you have an infinite loop, and that's bad news. We haven't actually had that many bad mistakes on this so far, unfortunately. So I say unfortunately, I like mistakes to happen, because then we know. So we have the score thing. It doesn't actually do anything. Let's actually display it in some way. So I'm going to put game manager on here. We can see the high score at least. We can't see the regular score because it is a property, and that makes it so we can't actually see it easily. Although we could do view debug, and we should be able to see the backing for it. Yeah, score. So let's just look at there and see if it's working. So, oh yeah, it won't be doing anything. So it just says 0, and it stays 0. That's because we didn't do anything. So all we're going to do is, and actually, can I do this? I'm not sure. We might have to write a script for this, but I'm going to see if we can do this. So if we go to our enemies, sorry, we're in debug, makes everything look really scary. If you see a bunch of numbers and stuff, go up here, go to normal. Looks less scary. Yay. So we have this on trigger. We can add another event here. And what we're going to do is we're just going to go to game manager, drag that in here, and we're going to... So this one actually worked for a couple reasons. First of all, I can't actually change the... So we can go to game manager, and we can try to change the score. But the problem is you can only just set it. You can't say add something to the score. So we're not going to be able to use the event system to just sketch this out, unfortunately. That's not entirely true. We could add to the game manager an add score function, and then we could call that and then give it a value, and it would add it to the score. That actually makes a lot of sense, doesn't it? I guess that's one reason why you would do a setter rather than a property. I'm thinking this out. Sometimes I figure out best practices while I'm doing the show. So, do we want it so we can do it this way, or do we want to just write something that just... Well, I mean, we have to write it basically in the same way anyway. So yeah, let's just make a setter function. Just do public... Actually, let's just make this less fancy. We'll do it all in the setter function. So we're just going to call it int score. We're going to get rid of that one. We're not going to make it public even. We're just going to make it private int. This means that other things can't see these variables, and it's just a way of keeping things organized because we're not going to actually want to directly access them. We're going to want to actually, we want to read the score. Public. There's probably a really right way to do this. It just feels like every single way I can do this is not exactly the way I should be doing it. Alright, whatever. It doesn't matter if we have duplicate ways to access this. We're just going to pretend that we're not going to use it the wrong way. So we're going to say that we're going to use the add score function. So public void add score int amount. Int means integer. It means just any whole number. Again, our scores are just all whole numbers. And add score, all it will do is score plus equals amount. And we will do if score is greater than high score, then I promise I will find a way to fix that, and then I'll make a video on it. No, score is greater than high score equals score. Save. And now we can do this. So if we go to enemy and we pull game manager in here and we do game manager add score, and we're just going to add 100 points or something. Now one problem here is if I hit apply here, it's not going to work. Yeah. The reason is the prefab can't know about game manager because the prefab exists in project space and the game manager exists in game space. And so this isn't going to work, is it? Anyway, we can just use that function anyway. I'm just going to, whoops. I'm going to undo whatever I just did there. We're going to get rid of this bottom one. I'm just going to click it here. Okay, so when you hit minus, it gets rid of the one that's selected. So we can select that one, hit minus, get rid of it. Okay, hit apply. It's gone from all the enemies. Yay. So all I'm going to do is just make it now. So destroy game object on the enemy. Let's just... Alright, we're just going to create a script called add score on trigger enter. So we're going to need a way to get this game manager no matter what. And so the way we're going to do that is we're going to make game manager know about itself. I know that sounds a little strange, but what we're going to do is we're going to have a public game manager instance. And in start, we're going to set instance equals this. So that means this is a special command that says, that means this script. That means that this variable now equals this script. And so when this happens in start, now other variables, oh yeah, public static game manager instance. The static is special. So a public game manager instance means that every object that had this would have a separate version of it, so you'd have to set it on each object. Static means once it's been set, it's there to access from anywhere. And I'll show you how. So we can now access this in our add score on trigger enter. Let me save everything first so that we can make sure that that's going. And all we're going to do is on trigger enter, so we're just going to do public float, int amount. Let's default it to something. And void on trigger enter. What are we going to do? So on trigger enter, we're going to add score. So we're going to do game manager dot instance, which is the instance that was set by itself, and dot add score amount. Save, play. We're just looking at the game manager here. It's not displaying on the screen or anything. And we're not getting any changes on the score or high score. Why is that? Oh, I didn't actually put this on the enemy. That's why. We want add score on trigger enter. Drag that onto the enemy here. And then we're going to hit apply. Now we're going to look at our game manager again. And we're going to see if these numbers go up. Yay, they're going up. And they're not going up an exceptionally extra amount that they shouldn't. If we manage to hit them with 2 bullets at the same time, I think they might go up twice with the way that we set it up, but we can fix little problems like that in a bit. We can also fix the problem of bullets going through things. One of the ways we could fix that, actually, we can do that right now. Let's just do it. On our bullet, this is something we didn't fix before last time. I just didn't really need to make an instantiation. I guess that doesn't really matter. So in our bullet, we're just going to create a unity event on trigger enter. Drag the helper, oops, plus, drag the helper in. Unity event helper, destroy game object. And we're just going to give it itself. Then we're going to hit apply. We don't need this bullet in the scene anymore. It'll just confuse us when it starts flying. And we hit play, and now we should not be able to shoot through. Why is it not shooting? Oh, it's not shooting because we've created a bug. So what happened is it says when I hit something, destroy it myself, and it's hitting our player. So perfect. This is a perfect example to see the collision matrix. We're going to just really quickly do this, and then we're going to call it a show. I'm going to go to project settings, physics. And we've got these layers, and we can set things on layers. So I'm going to create a layer for enemies. We're going to go to enemy here. We're going to do layer, add layer. We're just going to add enemies. Actually, I'm going to add enemies, player bullets. We already have, we don't have a player, so we'll create a player, layer. So now we've got a couple layers to work with. We're going to go to our enemy, and we're going to set it to enemies, hit apply. So now if we go to the other enemies, it says enemies, sweet. We're going to go to player, we're going to set it to player, and then we're going to go to bullet and set it to player bullets. And now we're going to go into edit, project settings, physics. We've got this collision matrix. It's got our new things that we just added to it. And what these means is these things will collide with each other. So player bullets should not collide with the player. So player bullets and player should not happen. And that should solve our problem. So if we hit play and hit Z, it's working again. And now it only kills one enemy and stops. All right. Let's call that an episode. Thank you very much for watching. If you have any questions, you can email me, max@max.cool. Pushypixels at pushypixels.com still works too, but max@max.cool is really short and really cool. Anyway, you guys have a good one, and yeah, good to see y'all. I'm kind of in the past, talking to you in the future, but it's still really great. Like, I feel you. And we'll be doing another episode next week. No promise on time, but there will be a new episode. Thank you very much, and see you guys next week.